let's go through and practice this. Now, biggest suggestion that I can give you as you do these, especially because we're doing them online, you're going to have the computer, use the scientific calculator from Desmos. There it is. When you go to plug these things in, you can make the expression on the left side match exactly to what you would have written down on your paper. It makes life a lot easier. So first part about this, we identify what type of growth and decay we have. Now, when I went through, I talked about, we had compound and continuous were the ones that we really focused on with our web pages, but we also kind of had normal, and that was when it was annual. But you're looking for two words here. You're looking for compounded, and then how it's compounded, annually and quarterly. If you see one of these with the LY words, that gives you this in value, and it allows you to break that percentage up. The one that's a little bit different is when you see this word, continuously. Continuously tells us a different formula. So for these first two, we're going to be using our balance is equal to our initial. Let me see if I can write that a little bit better. Our balance is equal to our initial, which is whatever we start with, 1 plus the rate in decimal form over this n value times this n value. And our real trick here is you got to identify each part of this formula. The part that gets tough, not really tough, but that's different, is this n. This number n comes from these ly words. It's how many of those things are in that year, in a year for that. So let's go through and identify all the other parts. So our balance, I'm sorry, not our balance, our initial is 5,000. That's what we're starting with. Our time is going to be 2 years. And this 4.5% that's in each problem is our rate. So this is our initial. This is our time. And this 4.5 is our rate. And really, we're just substituting into this formula. The only thing we need to find for these first two, we need to figure out what the n is going to be, because it's going to be different for each one. So balance is going to equal the initial, so we'll put 5,000. 1 plus the rate. Now here, the rate that we see, we're given a rate that is 4.5%. We can't do math with percentages. Percentages are another representation that this is really a decimal. And what we need to remember is that we've got to take this decimal point and move it to the left 2 places. We have to find the decimal representation of this, which is 0.045. I have to do that to be able to use this number mathematically. So this is going to be 0.045 on the top. And our time is 2 years, so we're going to put 2 up here. So the only thing I have left is this weird number in the bottom that's n. That n comes from the word annually. How many years are in a year? 1, right? There's 1 year in a year. So that means that this number here is going to be 1, and so is that one. That number n, which is what's going to change when we come down here, is based on this word, usually with an ly at the end. This tells me that n is going to be 1 for this problem. When I come down here and I write this one, this quarterly is telling me the n value for the problem. The n value here, how many quarters are in anything broken into quarters? 4. All right, break something into quarters, you get 4. This one tells you your n value is 4. If you look at the notes that I worked through where I went over this formula. We talked about it. I gave you a whole bunch of these n values. Yearly was 1 because there's 1 year in a year. Quarterly was 4. How many months are in a year? That's 12. Weekly. Now, weekly doesn't come out even if you do the real division. You're going to use 52 every time. It's not exact, but it's what's used for this calculation. Daily, 365 days a year. You don't have to worry about leap year. Don't worry about anything crazy like that. If it says yearly, if it says broken down daily, your n becomes 365 and you're good. You can continue this process for almost any measurement of time. Like if we went hourly, you probably don't know this one off the top of your head, but hourly you could use daily, which is 365 days a year. And then each one of those days is worth 24 hours. That'll tell you how many hours are in a year. We could now define minutely, we take the number of hours, multiply it by how many minutes are in each hour. That'll take us to minutely, and we see this number keeps getting bigger and bigger, okay? Down here, if you ever see the word semi in front of one of these, what it means is to double this. Double that one. I should put the arrow the other way on this side. If you ever see semi, what it means is take this and double it, meaning annually is normally 1, but semi-annually is 2. Semi-monthly would be 24 because there's 12 months in a year, and this means to double that. So if you ever see the word semi in one of the problems with the ly word, it just means double those things. That's about all of them that I could think we could come up with and see. Most of your work will be dealt with these 5. So try to commit those ones to memory. But you shouldn't really encounter too many after that. Okay? So that's where that n value comes from. So that's why this one's quarterly. Let's actually find the answer for this. So let's practice plugging this into the calculator. So I'm going to delete what's in here because we had done this before. And when you're using Desmos, the scientific calculator, I sent you a link earlier in the week and I said, hey, bookmark it because it's going to come in handy here. So what we're going to do is we're going to make our Desmos entry look exactly like what's here, because then I don't have to worry about simplifying anything. I don't want to round anything before I get to my final answer. I just want to get this exactly in and see what the answer would be out, and then I'll round it. So we need 5,000, 1 plus 0.045 over 1. So let me go back. So this was 5,000, 1 plus, and when you get this fraction inside, type the numerator, go back and highlight it, then hit the divide key, and it'll just put that on divide. This was 1 underneath there. And then power, you're going to want to come in here and hit this A to the B down on the right side. I'm in the function menu here, see? And then we're going to type our powers in. I'm going to put them in parentheses just because that's the same way that I had written it on the sheet. 2 times 1. So we come back up here and we go 2 times 1. I don't need to hit enter or anything else. It tells me the answer right here. So I'm actually going to screen clip this onto our problem so we can see it. So plugging this straight into Desmos, this is what I get as an answer. But I also need to be cautious because I'm going to have to round that. Because what are we counting here? We're counting money, right? How many decimal places does money usually go to? Goes to 2 places for pennies. So I only want 2 places for this answer. So that means I'm going to round here at this where this 2 is. And that's going to be based on the number next to it. 5 or bigger, that 2 turns into a 3. Less than 5, it stays the way it is. So that means the answer that I would need to write down $5,460.13. You've got to be cautious with your rounding here and make sure that you are executing that part correctly. Now, when we work down to B, because we're going to compare some of this stuff, the only thing that I'm changing is I'm changing this in value. I'm still 4.5%. I'm still $5,000. I'm still 2 years. So every part of the formula with the numbers in it stays the same except where I highlighted yellow here. So this balance is still going to look, it's going to look the same, except I need to change that bottom number here in the fraction to a 4, and then the number in top to a 4. So the only thing I'm changing with this is how many times that interest is applied. So let's go back to Desmos and make that happen. So 5,000, 1 plus 0.045, and remember, highlight that and then hit divide. But this time the number underneath the fraction is 4 because of quarterly. And we go up to the power, and this is still 2 years, but instead of being multiplied by 1, I change that end value. That end value is now 4. And there's my answer for that one. Let's drag this one over because this one is not as nice. So this calculation gives me that. And remember, I want to round at the second number after the decimal. So that means I'm looking at this 3. Since 3 is less than 5, that 2 stays the same. So this one should be written as $5,468.12. Now, we get to this last one. Percentages, time, initial investment stayed the same. I'm still compounding, but now I get this one called continuously. Continuously changed our formula. This is the one where we got the weird letter in our formula, where it looked like this. Time is still time. Rate is still the percentage in decimal form. Initial is still what we start with. We see the word continuously when it's asked. But here we get this different problem. Now this letter E actually is a number. What we find out as we start compounding more and more is that when you get into like minutely and secondly and stuff like that, you don't start seeing a difference because the change becomes so minute that you don't really see it anymore. And that limit that we approach is actually this number E right here. If we want to see what E is, if we come back to our calculator here, E is, now when you start this normally, it'll be right here on this function, this main tab. You need to click the FUNC button, which is function, and E is right here. It says E to the X. If I click that and I put a 1 in, it'll show me the value of E. E is this number 2.718281828, and it goes on forever after that. It's like pi. You don't need to remember what that number actually really is. What you do need to remember is how to use it and how it changes our formula that we apply for this. So that's the base of this. These rates and times are powers. Initials and multiplication. So this is going to look like this for this formula. Initial E rate times time. And both those things are powers. So when we go to find this balance, we still started with 5,000. E to the power of the rate, which is, remember it's in decimal form, 0.045. And then we're going to multiply that by our time, which is 2. So when you see continuously, the formula changes. Now we're going to plug that in exactly the way it looks into our calculator. So we had, you can delete what we have here, 5,000. Then I'm going to come here and hit the E to the X button, and it's automatically going to make that a power. I'm going to put parentheses just to be safe, 0.045 times 2. And it tells me that this is the answer. Now we still need to round that just like we did before. So second place again, because this is still money. So we're looking at that 7. And the number next to the 7 is a 1. So that means that 7 stays the same. And we should get $5,470.87. Base thing, get these right when you go to plug in and find the answers. Don't round anything until the very, very end. And that Desmos calculator, Desmos scientific calculator makes that really nice. All right, so now we get into the comparing part. How much more money do we earn compounding quarterly instead of annually? So they're asking us to compare two different numbers. So quarterly, we made $5,468.12. Annually, we would have made $5,460.13. Which one of those more? Quarterly or annually? Quarterly. And if you look at continuously, continuously is kind of where you max out. Continuously is even more than quarterly. If I did this problem, I found monthly. Monthly would fall between quarterly and continuously. The more times you compound, the more money you'll end up with in the end. Okay? But if we look at this, we want to compare. So how much more money quarterly than annually? That asks me to take these two numbers and subtract them. And I'm pretty sure that's $7.99, right? So that means we made $7.99 more. So when you're asked to compare these things, you've got to go through, apply the right formula, and find those values. Usually it's going to ask you which one's more, how much more you made, how much profit you made would be another one that you'd need to look at. So let's actually look at that. How much interest did we make? Let's do yearly. So what did we make when we put this in and our interest was applied yearly? That was our $5,460.13. So we know that at the end of 2 years, we had $5,460.12. That was it, wasn't it? Or was it 13? Oh, it was 13. Which part of this number is the interest? How much did we put in the account? We started with our initial was $5,000, right? And then that's our money. That's what we started with. Interest is how much more did they give me after this time? So if we wanted to know how much interest we made, well, we need to take what we ended with and subtract our initial amount. And that would tell us that we made $460.13 in 2 years by just leaving our money in a bank account.